The Artemis II crew will travel farther from Earth than any human being in 50 years. And there is a region of the moon they will pass a place where no sunlight has reached in billions of years, where NASA's own instruments have detected something that does not fit any existing model of lunar 45 minutes. That is how long this crew will disappear. No radio, no telemetry, no heartbeat from mission control. No voice from Houston saying, "You're go for burn." Just 4 human beings behind a dead world in a silence so complete it has no parallel in the history of human exploration. This is not a failure of technology. This is physics. And what the crew encounters on the far side, what is waiting in those permanent shadows, may force us to rewrite everything we thought we knew about the moon's origin. Most people understand Artemis II as a milestone, the first crewed lunar flyby since Apollo 17 inches 1972. 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Canadian astronaut Jeremy Hansen, are looping around the moon at roughly 8,900 meters per second and returning home. What most people do not understand is the trajectory. Artemis II will not orbit the moon in a perfectly circular orbit. It will follow what NASA calls a hybrid free return trajectory, a gravitational slingshot path that takes the crew behind the moon through its shadow and past the southern polar region. That southern region, the area near the Lunar South Pole, is where the story changes. Because the moon is not what we thought it was. For decades, the Lunar South Pole was considered geologically inert, ancient, dead, a relic of the solar system's violent formation, baked and bombarded into silence 4 billion years ago. Then the instruments arrived. India's Chandrayaan-1, NASA's Lunar Reconnaissance Orbiter, the L-Cross impactor that deliberately crashed into a southern crater in 2009 and kicked up a debris plume. Scientists are still analyzing. What they found in those permanently shadowed craters that have not seen a single photon of sunlight since before complex life existed on Earth, did not match any prediction. And in 2025, the findings got stranger. What specifically changed in 2025's data? To understand what Artemis II will experience behind the moon, you have to go back to the 19th of July, 1969. Michael Collins did not land on the moon. Neil Armstrong and Buzz Aldrin did, and history recorded every second of that descent. But Collins, alone in the Columbia Command Module, did something far stranger. He orbited. He waited. And every 127 minutes, he passed behind the moon. For 48 minutes of each orbit, Collins was more isolated than any human being who has ever lived, or likely ever will. No radio contact. No sight of Earth. The darkness on the far side was total. Not metaphorical total, but physical, absolute blackness, interrupted only by stars so bright and undistorted by atmosphere that Collins later described them as hard, sharp-edged, aggressive, unlike anything he had seen from Earth. He wrote afterward, "I am alone now, truly alone, and absolutely isolated from any known life. I am it." 27 people have traveled to the moon. 24 of them experienced the far side silence. Every one of them described it differently. Some found it peaceful, a cathedral quiet that felt earned. Others described a specific unease they struggled to articulate. Apollo 15's Al Worden called it awareness. The sensation, irrational but visceral, that you are being observed from a place you cannot see. NASA's psychiatric evaluations from the Apollo program identified a consistent anomaly. The psychological response to far-side silence was not predicted by pre-flight simulation. Crews reported it as qualitatively different from the silence of open space heavier, somehow directional. Multiple astronauts described an involuntary impulse to check systems that needed no checking, to reach for a switch, to do something, anything, to push back against a quiet that felt, in their own words, inhabited. That was 1,969 through 1,972. Small capsule. Limited instruments. No persistent data gathering capability. Artemis II carries tools that crews did not have. And the data those tools are already sending back from robotic precursor missions that have been mapping the Lunar South Pole for the past 3 years is the reason certain people at NASA are choosing their words very carefully. Why are NASA scientists being careful with language? Permanently shadowed region, PSRs. That is the technical designation for the craters near the lunar poles that the geometry of the moon and sun conspires to keep in eternal darkness. The sun never rises above their rim walls, not in summer, not in any season, not in 4 billion years. Inside those craters, Temperatures drop to minus 250 degrees Celsius colder than the surface of Pluto, cold enough that volatile compounds, water ice, carbon dioxide, ammonia, methane, do not sublimate. They do not evaporate into space, they stay, accumulate, layer by layer, over geological timescales, building concentrations of frozen material that should not, by any reasonable calculation, exist on an airless, geologically dead world. Here is what that means in human terms. The moon has been quietly collecting the chemical building blocks of life delivered by comets and asteroids over billions of years and storing them in a natural deep freeze with better preservation conditions than any laboratory on Earth. That alone would be remarkable. But it is not the part that disturbs researchers. In 2024, data from NASA's Lunar Flashlight mission, a small satellite designed specifically to probe the PSRs with near-infrared lasers, returned spectral signatures that did not match pure water ice. The reflectance patterns were anomalous, complex. The mission team published their initial analysis with cautious, heavily qualified language. The signatures were consistent with, but not exclusively explained by, hydrated mineral compound. Translation: something in those craters is reflecting light in a way that water ice alone cannot fully account for. What organic compounds have been detected, and what is their origin? Subsequent analysis by independent teams, cross-referencing LC Ross plume data, found carbon chain molecules, organic compounds in concentrations and combinations that match the chemistry found in carbonaceous chondrite meteorites, the same class of meteorite that, on Earth, has been found to contain amino acid, nucleobases, the precursor molecules of biological chemistry. The moon does not harbor life. That statement is important and must be said clearly. But the moon may be harboring a 4 billion-year fossil record of the same chemistry that produced life on Earth, preserved in those lightless craters, with a fidelity that no terrestrial geological record can match. And Artemis II will pass directly over the region where the densest concentrations have been mapped. The crew will see nothing. But what is below them changes everything. Christina Koch has spent 328 consecutive days in space, the longest single spaceflight by a woman in history. She knows silence. She knows the particular psychology of confinement, of watching Earth turn you below through a small window while systems hum around you and the world outside is lethal in every direction. She has described the moment of orbital sunrise when the sun clears Earth's limb, and the station floods with gold as a daily reminder that the universe is not hostile, it's just indifferent. And that's actually beautiful. She will experience something different behind the moon, because orbital sunrise on the space station is reliable, predictable. Every 90 minutes, the light returns. Behind the moon, the light does not return on a schedule you can feel. It returns when the trajectory says it returns. And for those 45 minutes, the math is all you have. Victor Glover, who spent 167 days aboard the International Space Station during Expedition 64, has spoken in interviews about the specific discipline required to manage the emotional weight of long-duration spaceflight. You have to be very deliberate, he said, about where you let your mind go. Because where your mind goes, your focus goes. And your focus is never, ever optional. Reed Wiseman, the mission commander, carries a different kind of awareness. He has flown combat missions. He understands the psychology of operating in an environment where the variables exceed your ability to anticipate them, where training runs out and something else has to take over. He has been asked about the far side blackout. His answer was precise. We train for it, we simulate it, and then we'll do it. That's the job. What that answer doesn't capture, what no pre-flight interview can capture, is the moment the signal actually dies. There is a specific second. Mission controllers in Houston know exactly when it's coming. They watch the clock, they watch the signal strength meter, and they say what needs to be said in the final moments before loss of signal. Artemis II, you are go for the lunar far side. We'll see you on the other side. And then, nothing. The screens in Houston do not go dark. They stay on. They continue displaying the last known telemetry, altitude, velocity, crew vitals, frozen, because there is nothing new to display. Controllers do not leave their consoles. They sit. They watch frozen numbers. They wait. Jeremy Hansen, the first Canadian to travel beyond low Earth orbit, has a physics background. He understands exactly what is happening to the radio waves. They are not being blocked precisely. They are simply no longer aimed at Earth. The moon's bulk is between the antenna and the home. It is geometry, not malevolent. And yet, He has said that he expects the silence to feel earned, that there is something right about 4 human beings going somewhere no signal can follow. We're not supposed to be able to reach back, he said. That's the point. At closest approach, the Artemis II crew will be approximately 8,900 kilometers from the lunar surface, during the far side pass, close enough to see the geography of a world no human eye has observed directly since Gene Cernan lifted off from Taurus Littrow in December 1972. The far side of the moon is not what the near side looks like. The near side, the face we see every night from Earth, is scarred by ancient lava flows called Maria. Dark, flat plains that formed when meteorite impacts breached the crust and flooded basins with magma. The far side has almost none of this. It is the highlands that are almost entirely cratered, ancient, geologically unprocessed by the volcanic events that shaped the familiar face. It looks, in photographs, like a different world entirely. Scientists do not fully understand why. The leading hypothesis, the giant impact hypothesis, proposes that the moon formed when a Mars-sized body called Theia struck the early Earth approximately 4.5 billion years ago. The debris coalesced into the moon, but the asymmetry between the near side and far side has never been satisfactorily explained by this model. The crust is thicker on the far side, the composition differs, the volcanic history is absent where it should, by the laws of planetary science, be present. And now, in those southern PSRs and craters, that will be below the Artemis II crew as they make their closest approach. There are chemical signatures that don't fit the standard model of how the moon assembled itself. Some researchers have begun asking a question they would not have asked 10 years ago. Are the organic compounds in the PSRs indigenous to the moon, part of its original formation chemistry, or were they delivered after formation by the same bombardment events that may have seeded Earth with the chemistry of life? Because if the answer is delivered, if the same comet and asteroid impacts that potentially brought life's precursors to Earth also deposited them on the moon, then those frozen craters are not just a resource, they are a shared archive, a record preserved in the cold of where we came from. The Artemis II crew will not land. They will not retrieve a sample. They will fly over and look down and know that what is frozen in those shadows has been waiting undisturbed, in complete darkness, for longer than complex life has existed on this planet. We have spent 50 years talking about returning to the moon as if the moon were a destination, a checkpoint, the first leg of a longer journey. But the data from the South Pole craters suggests something different. It suggests the moon is not a waypoint. It is a witness, the oldest, most perfectly preserved witness to the chemistry that made us. And we are only now, in the second decade of the 21st century, learning to read what it recorded. 4 people will pass over those shadows, 45 minutes of silence, and on the other side, they will re-emerge into signal-range voices, returning from the void, changed in ways that none of them and none of us can fully predict in advance. If you want to understand what the crew faces the moment, Signal returns the 8-minute burn that determines whether they come home or remain in lunar orbit indefinitely. That is the next chapter of this mission, and it is not the one NASA discusses in press conference.